Hello everyone, and welcome to Load of Scit. Today we will be talking about the different types of sum approximations. First we need to answer this question. What is sum approximation? Sum approximation is a way to easily estimate the area underneath the curve using specific points. Over a set interval, the graph is divided into smaller subintervals. The area of those subintervals are taken using their width and height, and then added together to estimate the whole area. Usually this is done using information given by a table of values or the function itself. In this video, we will show you how to do so using a table. The subinterval width may vary throughout a single problem, but for now we will keep them equal. There are two major types of sum approximations in calculus AB. The first is Riemann sums, in which the section is a rectangle, the height of which can be on the left, middle, or rightmost point on the subinterval. Remember that the area of a rectangle is base times height. The other type is trapezoidal approximation, in which, you guessed it, the subinterval is a trapezoid, and to calculate the area, both the left and right height is needed. The area is 1/2 base times height 1 plus height 2. To start, let's go over a right Riemann sum. The graph is being divided into 4 equal subintervals. To get the distance between subintervals, one subtracts the lowest x value from the highest one. 5 minus 1 equals 4, and then divides the number by the number of subintervals. 4 divided by 4 equals 1. Each subinterval is 1 unit wide. Because it is a right sum, we will be making the rectangles from the right side of each. The heights will be f of 2, f of 3, f of 4, and f of 5. To get each area, multiply the height by the interval width. 1 times 12 equals 12, 1 times 34 equals 34, 1 times 31 equals 31, and 1 times 1 equals 1. Now add them together. 12 plus 34 plus 31 plus 1 equals 78. The approximate area under the curve is 78 square units. Now for a left Riemann sum. We'll use the same table, but let's see how the answer changes. This time, we will be using the left values. Either pause the video and do it yourself, or watch the answer now. 82 square units. The initial setup is the same as the right Riemann sum, but this time we are using the heights dictated by the left values, f of 1, f of 2, f of 3, and f of 4. The areas of each are 5, 12, 34, and 31. Added together, we get 82. By taking from different areas on the curve, the area will change as the areas of the subintervals change based on which height was used. Before we move on to midpoint and trapezoidal sums, here's a skit.
You know, the night sky is really quite amazing when you think about it. Beyond our own solar system, there are 100 billion stars in our own galaxy and about that many planets. And there are probably about 6 billion Earth-like planets in our own galaxy. And there are 2 trillion galaxies in the entire observable universe. And yet, the observable universe only makes up about 5% of what's actually out there. And yet, right here, we're the only planet that we know of that actually has life on it. That makes you pretty darn special. And this has been a Skit.
To better show how to do a midpoint Riemann sum, we'll use new values. Using 3 subintervals, calculate a midpoint Riemann sum using these values. To do this, interval width is calculated the same way. 8 minus 2 equals 6, 6 divided by 3 equals 2. Each interval is 2 units wide, so 2 to the 4, 4 to the 6, and 6 to 8. Remember, being a midpoint approximation, take the middle value. If you think you could do it on your own, pause here. You should have gotten 42 as your answer. This is done by multiplying each width by the middle height of each interval. In this case, that was f of 3, f of 5, and f of 7. This would give 2 times 4 plus 2 times 9 plus 2 times 8, which equals 42. Now, in a trapezoidal sum, the process is similar, except we're using trapezoids instead of rectangles. This is often more accurate than Riemann sums because it allows for the slope of the subintervals to change as it would on a curve. Let's use the same table. So, here you will be using both the left and right values of the subinterval to calculate the area, as both heights are needed for the trapezoid. Knowing the formula of a trapezoid to be this would give you 1/2 times 2 plus 5 plus 1/2 times 2 times 5 plus 10, plus 1/2 times 2 times 10 plus 6, which would equal 38. Here at Little Scit, we hope we've helped you to feel a little more confident in calculus class, knowing the basics of sum approximations. Now on a test, it's going to be a bit more complicated than this, but this still goes over the same rules that every problem will have. This has been Little Scit. Don't forget to like and subscribe. We need you.